Good morning, everyone. Hope all is well. Hey. All right, so we are looking to get into, we were in 1.5, we need to finish 1.5. Okay, so last thing we did, 1.5, we started quadratic equations, did the zero factor property. So now we're starting with the square root property. Oh, somebody's trying to get in. And we're going to look to hopefully finish up 1.5. We'll see. All right. Yep. And today is Wednesday, so then we'll send everybody off into the weekend, right? All right. So square root property, another way of solving quadratic equations, says if u squared is equal to d, then u is equal to the plus or minus square root of d. So this right here is something you have to hold on to. Whenever you take the square root of both sides, trying to solve for your variable, decide where the square does not cancel. That's going to be plus or minus square root of whatever's on the other side. So simple example here, we have x squared equal to 25. If I want to solve for x, remember I need to undo what's being done to x. So x is being squared. So I take the square root of both sides. So taking the square root of both sides. Somebody's trying to, hold on. Taking the square root of both sides will cancel out the square and the square root on the left. And then on the right, I have the square root of 25. But the square root property says that if I have to take the square root of both sides, then plus or minus has to be involved. And the reason being is because when I take the square root of 25, remember, we want to know all of the values that will give me this result as far as x is concerned. So positive 5 times 5 is 25, but also negative 5 times 5. Negative 5 times negative 5 is 25. So that's why you have to give an account for both the positive and the negative result. So take the square root of 25, which is 5, and that's why your answer is going to be positive and negative 5. And once again, remember we talked about when you're solving your quadratic, you should get two solutions. And so that's how you get your two solutions, positive and negative 5. So once again, whenever you take the square root of both sides, going to solve, positive and negative, plus or minus has to be used on the sign in which you didn't cancel that square root and square root. All right. Erase some stuff. All right, so we have 9x squared plus 25 equal to 0. So you want to solve for x. So what we can do is go ahead and subtract 25 from both sides. Is canceled on the left, leaving you with 9x squared equal to negative 25. Now we can divide by 9. 9's cancel. Now we have x squared equal to negative 25 over 9. Next, take the square root of both sides. Square and square root cancel on the left. And then on the right, we have plus or minus square root of negative 25 over 9. And that's because we took the square root of both sides. And then go ahead and simplify that. The square root of negative 25 is 5i. Square root of 9 is 3. So we have plus or minus 5i over 3. All right, any problems? All right, original problem, x minus 2 squared equal to 6. So we need to get this square off of the quantity so we can get access to the x. So you take the square root of both sides. So square and square root cancels on the left. Then on the right, you have plus or minus square root of 6. Now we can't take the square root of 6 evenly. So it's okay to leave it as the square root of 6. And then we will add, not subtract, but add 2 to both sides. And we have 2 plus or minus square root of 6 as our answer, our final answer. All right. So not sure if my math lab, oh, see how my eraser up. Not sure if my math lab has added the plus or minus option yet. It may have, I can't remember because I got other programs in my head right now. But if they haven't, then you have to write it out and just do 2 different solutions, 2 plus square root of 6, 2 minus square root of 6, if they do not have this plus or minus symbol. But yeah. All right, any problems? All right, next one, x plus 4 squared equal to 81. So once again, we're trying to get access to x. The squares on the parentheses, keeping that parentheses there. So we need to take the square root of both sides, canceling out the square on the left, give you x plus 4. And then on the right, that's plus or minus square root of 81. Take the square root of 81, which is 9. So that's plus or minus 9 on the right. And then you subtract 4 from both sides. So it's negative 4 plus or minus 9. Now to finish off this problem, you are expected to go to that next step. Remember the last one, we didn't have solid number of, when you look at the square root of 6, you couldn't simplify that. So we just left it as the square root of 6, and you cannot combine 2 and the square root of 6 by adding. But we do have negative 4 plus 9 and negative 4 minus 9, and we are expected and can add 9 and 4 together. So you would go ahead and finish that off by negative 4 plus 9, which is 5, negative 4 minus 9, which is 3. Right here, I'm just saying this is another example where you don't have to go to the next step because you cannot add a real and an imaginary. So leaving it like this is okay. But when you can combine these terms, they are expecting you to do so. All right, questions before I scroll up? All right, next process is completing the square. So we actually have steps for this one. So we want to solve the equation, solve when the equation is in this form, ax squared plus bx plus c equal to 0. So in other words, one side has to be set equal to 0 initially, when we're talking about these steps. So And then also when we're referencing A, B, and C, A is the term that's attached to x squared, B is the term that's attached to x, and then C is your constant that's not attached to a variable at all. So when we're talking about, when we reference A, B, and C. So the first one, if A is not 1, then divide both sides by A. In other words, you're going to divide each term by A if A is not 1. 2, we're going to isolate C to one side of the equation. In other words, we're going to take that C over to the other side. 3, we'll take half of B and square it, and then we'll add the result to both sides of the equation. Four, factor the perfect square trinomial, simplify the other side. Five,
Mr. Tucker,
yes.
so I'm sorry, I'm like still on number 1. It says if A doesn't equal to 1, then divide both sides by A or each
Yes,
term
by A.
by A.
And
Okay.
all I'm saying is that we're going to divide each term by A. Yep.
Gotcha. Okay, thank you.
Yep, no problem. Yep, so 5, it says solve using the square root property. And 6, yep. And 6 is just check. Give you guys a chance to write that down. All right, and we're still copying. Okay, so let's look at the first one. First example, x squared minus 6x plus 4 equal to 0. So first step, it says if A is not equal to 1, that means if A is equal to 1, then there's nothing to do. So here we recognize that A is equal to 1. So we don't have to do anything for the first step. And the next one we'll do one with A not being equal to 1. But the first step we don't have to do because A is equal to 1. Second step is to isolate the constant. So we have plus 4. So we subtract 4 from both sides. And now we have x squared minus 6x equal to negative 4. Any problems? Third step, take half of your b term. B is negative 6. That's what's sitting in front of x. You take half of negative 6 and then square it. So half of negative 6 is negative 3, then square it. That gives us 9. And then to finish it off, we add 9 to both sides of the equation. So x squared minus 6x plus 9 equal to negative 4 plus 9. Any questions so far?
So why is it that for steps like 3, you're taking half of B? Why is it that you're only doing half of B and not all of B?
Well, part of the process is to take half of B and then we're going to square it, and that gives us 9. Now it's going to show up in a second as to why we're doing it, because what we're doing is called completing the square. We are creating a perfect square trinomial so that we'll be able to solve using the square root property. And see, when you're dealing with math, if you can manipulate the problem in such a way that if you do it to the other side, the left side, and do it to the right side, you haven't changed anything. So if you can find a number to help you along with your solving process, to help you use another method, and this is something that you will, if you go to calculus, that you most definitely will be using in calculus, the thought process of manipulating the problem in such a way that I can do something else to it to help me to solve it. And so that's what we're doing. By taking half of your B term and then squaring it and then adding it to both sides, I create this perfect square trinomial. And now I can factor that and create this situation right here. And so now I'll be able to apply the square root property and take the square root of both sides and then keep solving and get my answer.
Okay.
Yeah. So all of it, good question. But all of this is done so that we can create this scenario, which will create this scenario, and then we can use our square root property in step 5. Yep.
Okay.
All right. So, yep. So going into step 4, like she just mentioned or asked, this is why we do it, so that we can create this trinomial right here. And even if you're not comfortable with factoring, whatever half your B term was or is, that's what goes right here. So you have x minus 3, no matter what it is, whatever half your B term is, that's what goes right there with x. And that will always work. And then, of course, on this right side, negative 4 plus 9 gives me this 5 right here. So that fourth step is to factor out that trinomial and then simplify what's on the right side. Once you have that, once you factor correctly and simplify on the right side, we can go ahead and solve. And next move is to take the square root of both sides. Notice my square and square root cancels over here. And then on the right, we have this plus or minus. Don't forget, whenever you take the square root of both sides, you have to do plus or minus on the other side. And then we can finish it off by adding 3 to both sides. And that's our answer, 3 plus or minus square root of 5. Any questions, any questions? All right, scroll up and try it again, but okay. All right, so the next one, 9x squared minus 6x minus 4 equal to 0. Now this time a is not equal to 1, a is equal to 9, so we need to not multiply. Well, you could say multiply, but we're going to divide each term by the 9. Divide both sides by 9. In other words, divide each term by 9. So that gave us 9x squared over 9 minus 6x over 9 minus 4 over 9 equal to 0 over 9. Then when you simplify that, those 9's cancel. 6 over 9 reduces to 2/3. 4 9 stays the same, and then 0 over 9 is 0. All right. Then we need to get 4/9 to the other side. That's our constant. So we add 4/9 to both sides. So x squared minus 2/3 x equal to 4/9. All right. Third step, take half of the b term. This time that b term is 2/3.
So in step 2, it's 2/3x and not 2x/3.
It's the same thing. Those are the same thing.
Okay.
Yep. Just preference in how you want to write it. But 2x/3 and 2/3 x, the same exact thing. All right. So 1/2 times negative 2/3. You can go ahead and cancel out those 2's. And so that'll give you negative 1/3. And then squaring negative 1/3 is 1/9. No, negative 1 squared is positive 1, and then 3 times 3 is 9. So that's 1/9. Then we add that 1/9 to both sides of the equation, and that's the end of step 3. All right. Now, step 4 is to factor that trinomial right here and then add these together. So going back, remember I said that even if your factoring skills are not the greatest, whatever half that b term is, which was negative 1/3 for us, is what goes along inside that parentheses with x. So that's why we have x minus 1/3. That was half of our negative 2/3. So once again, you really don't have to lean on your factoring skills. Just remember that when you take half of b, that's what go in here with your x for your parentheses, inside of your parentheses. And then 4/9 plus 1/9 is 5/9. All right. Step 5, we can now solve this by taking the square root of both sides. Take square root of both sides. Say square root of the left side, excuse me. Square root and square cancels out. Then on the right, square root of 5/9 will be plus or minus. Don't forget your plus or minus. So now here, we can reduce this sum, but not all the way like we did before. You take the square root of both top and bottom. The 5, we can't simplify that any, so we can leave that there, but we can take the square root of 9. So that would be square root of 5/3. And so this is what we have up to this point. X minus 1/3 is equal to plus or minus square root of 5/3. And now we can add 1/3 to both sides. 1/3 cancels on the left. Then that gives us 1/3 plus or minus square root of 5/3. So you can write it either way as far as your answer is concerned. Questions on the process or the steps?
Would it be possible to do another example?
Yeah. Anybody still copying? See if I got one already written. Yeah, don't have one up there. Still with it. Let me see if I can find a good one. Or I just make up one. Guess this one's okay. All right, 4x squared minus 4x minus 1 equals 0. So first thing we'll do is recognize that a is not equal to 1. So we need to divide both sides by 4. So that'll be x squared minus 1x minus 1/4 equal to 0. So next step, we want to isolate the constant. So we're going to add 1/4 to both sides. All right, any questions so far? All right, so 3 is to take half of your b term. B is -1. This was sitting up in here. Yeah. So half of -1 and then square it. So half of -1 is just multiplication. 1/2 times -1 is -1/2. And square that, that's positive 1/4. Then we add that 1/4 to both sides of the equation. All right, fourth step is to factor this. And remember, whatever half your b term was is what goes here. Then add the other side, that's 2/4. which can reduce down to 1/2. No, I guess I'll leave it just in case this happens. All right, any problems before we look to solve it? All right, so now take the square root of both sides. All right, so now when I look to simplify this, that's going to be 1 over the square root of 2. Don't forget, whenever talking about having a square root in your denominator, they don't expect you to leave that there so you can rationalize. Multiplying, you know what? Well, my math lab, we'll see. Anyway, you can always try putting your answer with the radical in your denominator. Normally, I know they used to make you rationalize the denominator. In other words, if you have a radical in your denominator square root, you just multiply top and bottom by that. And so you can get rid of your square root in your denominator, rationalizing your denominator. So that'll give you square root of 2 over the square root of 4. And that'll just be square root of 2 over 2. And that's the answer that you would continue on with. So now you don't have a, radical in your denominator. Normally that is the case. All right. And then to finish it off, we'll add 1/2 to both sides. Mm-hmm. All right, questions.
So for our exams and our tests, would you rather us factor out the square root on the bottom?
Whatever my math lab asks of you.
Okay.
So if my math lab lets you continue on with the radical in your denominator, then I'm fine with that.
Okay.
Yeah. All right, so can we go back to the last ones? Everybody done copying? All right. So last method, quadratic formula. So you're able to solve for x by using the formula of negative b plus or minus square root of b squared minus 4ac over 2a, where ax squared plus bx plus c is equal to 0. That's just emphasizing once again that you want to set one side equal to 0 before you start this process. This. So the first example, 8x squared plus 2x equal to 1. So first thing we want to do, once again, is to set one side equal to 0. So we will bring the 1 over. by subtracting 1 from both sides. And now we have 8x squared plus 2x minus 1 equal to 0. So you can't pick out what A, B, and C are unless first one side is set equal to 0. Once you've done that, then you can establish your variables and the numbers that go along with them. So A is going to be 8, B is going to be 2, and C is going to be -1. Once you've done that, you can plug them into your formula accordingly. Don't forget this negative out here, so make sure you hold true to that. Sometimes people leave it off. So that's -2 plus or minus 2 squared minus 4 times 8 times -1 over 2 times 8. Under the radical, 2 squared is 4, -4 times 8 times -1 is positive 32. Four plus 32 is 36. Square root of 36 is 6. All right, so just like before, whenever you have numbers that you can go ahead and add and subtract from each other, they are expecting you to do so. So we have -2 plus or minus 6 over 16. I'll scroll up too far, let me know. So we go ahead and break it up as -2 plus 6 over 16, -2 minus 6 over 16. And that'll be 4 over 16, which is 1/4, and then -8 over 16, which is -1/2 when you simplify. All right, any questions before we do another one? Okay, next one is 3x squared minus 2x plus 4 equal to 0. Now here we already have one side set equal to 0, so that's good for us. We don't have to do anything extra, and we can just pick out what A, B, and C are. So A is 3, B is -2, C is 4. Once you've established what A, B, and C are, you can go ahead and plug them into your formula. So once again, emphasizing here, don't lose this negative. A lot of people tend to do so, especially when you have that B that's already negative. So make sure you don't lose it. So that's going to be -2 plus or minus the square root of -2 squared minus 4 times 3 times 4 over 2/3, not 2/3, over 2 times 3. All right, negative to negative is positive, so we have +2. Under the radical, -2 squared is 4. Then we have -4 times -3 times 4, which is -48. under the radical still, we have 4 minus 48, which is negative 44. And then in the green, I went ahead and broke that up. Let's see if I can magnify it. So once again, you are expected to simplify where possible. So that negative 44 under the radical, I broke it up into negative 4 times 11. Taking the square root of negative 4, that gives me 2i. So that's 2i square root of 11. So that's what's going on right here. So now we have 2 plus or minus 2i square root of 11 over 6. 2 times 3 gave us 6 in the denominator. And we can simplify this, but we also have to break it up. Don't forget standard form, because we have an imaginary part and a real part. We have to take the 6 into each term and break it up. 2 over 6 plus or minus 2i square root of 11 over 6. And then we can simplify it to 1/3 plus or minus I square root of 3, square root of 11 over 3, excuse me. All right, questions. All right, very good, then that's it, yeah. So that is it for 1.5. I would go into 1.6 at least a little, but unfortunately I have a funeral on Friday, and they were asking if I could take something to the funeral home. So if I found time, I would try to do that. So this is a good place to stop. And I can go ahead and knock that out real quick. But before I do so, did anybody have any questions before we close out? Very good. Just, told y'all that, just trying to be transparent.
I have a question.
Yes.
So I see that you're recording this. Are you going to be posting it?
Oh yeah, most definitely. So
Okay.
did you see the lectures from last week?
I haven't checked yet. but-
Okay, so I'll send them out in an email before the week is out. But if you just by some chance you miss my emails, you can always go to Canvas announcements, and one of the announcements would be entitled. I always archive all of my emails in Canvas announcements. So if you go to your announcements in Canvas, they'll be there, and it will be titled class lecture links. And so last week's will be in there, and then this one will be a new email that I'll send out. Hopefully I can get it out today.
Okay, thank you.
Yeah, no problem. All right, anything else, anybody else? All right, so you guys have a good one, be safe. Have a great weekend. If you have any questions, feel free to shoot me an email. I know I have some emails I need to respond to from yesterday. So if you shot me anything yesterday, gonna get to that soon. Other than that, you guys have a good one and take care.
Take care.
Everyone, thank you.
Thank you, take care, bye-bye.
Have a good day.
Later.
Thanks, you do the
Have a
same.
good day.
Thank you, appreciate it.
Have a good day.
Thanks, you do the same.